Our next presenters, shifting into high gear, we've got Karen Larson and Matt Miller. I'll let them come up and introduce themselves and take it away, guys. Welcome.
Thanks.
Don't fall down.
Hello, everyone. I'm Karen Larson. I'm the Senior Director for Product Management at Uniken. And
I'm Matt Miller, Technical Lead at Cisco Duo.
Yeah.
Thanks for coming on out. So this morning, Karen and I want to dig a little bit deeper into WebAuthn. We want to talk a little bit about the difference between WebAuthn and passkeys. Karen's going to help make sense of a lot of the acronyms that you're going to run across if you haven't already begun down the passkeys path. Talk about, you're going to hear the word attestation a lot today, so we're going to help make sense of that, and also talk a little bit about how you might use some of the information out of that.
They provide systems.
So I want to kick things off by talking about the difference between WebAuthn and passkeys, because you hear them seemingly interchangeably, like what's the difference between them? So WebAuthn is the original part of FIDO 2. If you think of FIDO 2 as a big umbrella, there's three actors underneath it. You have the website on one side, you have the browser in the middle, and then you have the authenticator on the right-hand side. WebAuthn is this portion over here that helps the website and the browser begin a WebAuthn ceremony, begin a FIDO 2 ceremony. So that is, of course, WebAuthn registration and authentication use public key cryptography. There's a private key that signs a value and a public key that the relying party gets via WebAuthn to verify the signature with the private key. As it's a browser API, here in the FIDO Alliance, CTAP is, so FIDO Alliance owns CTAP development, but the W3C owns WebAuthn because WebAuthn is a browser API. So that's sort of the fundamentals of what WebAuthn is in a nutshell. But passkeys is still WebAuthn. So when you hear somebody go, yeah, I protected my website with passkeys, under the hood, they are making WebAuthn calls to leverage passkeys and protect their account sign-in. The difference is that passkeys are an opinionated use of WebAuthn. So there's this concept of a discoverable credential in WebAuthn where when that key pair is created, the private key persists on the authenticator, and then the authenticator can sort of do what it wants with it. When the authenticator is able to synchronize those private key and make it available across different devices, we call that creatively multi-device passkeys. In the case of a security key, for example, security keys can also facilitate passkey authentication because they support discoverable credentials. And, but, of course, a security key's private key will never appear from a different device or a different security key, so that's called a single device passkey. So in the end, what passkeys represent is a marketing-friendly term for WebAuthn-based or discoverable credential-based WebAuthn authentication. That's really what the differences are. So now that we've helped you make sense of that, Karen's going to talk about some of the extra signals and acronyms and stuff you'll run across.
So for day one, we thought it would be a good idea to just cover some of the different terminology that you'll be hearing throughout the conference and what some of those things mean. There are a lot of acronyms. There's a lot of terminology that's part of WebAuthn. And if you're new to authentication, if you're new to identity security, sometimes these are not self-explanatory, I would say. So what we've put together here is just a quick cheat sheet. We're going to run through these and then talk about them a little bit more in depth. First is UP, or user presence. This is a check to make sure that there is some kind of person or gesture that's happened on the other side to make sure that you're not getting a pre-programmed authentication. After that, we have user verification. User verification is usually a check. It could be a knowledge-based or something like a biometric to be kind of a way of further identifying that you have the right person that's using that credential. There's a couple new ones that we're going to be digging into a little bit more today. User presence, user verification, UVUP have been around for a while. There's a couple new flags that we're going to talk about. One is BE, and that stands for backup eligibility. And then the other one is BS, which stands for backup state, not something else you might think of when you hear BS. And those two are a little related, and we'll talk about those a little bit more. when we look at what information we're actually getting back between the client and the RP as part of that create credential check. We also have AT, which is attested credential data, which is long, and we will talk about that a little bit more in the presentation, but just remember AT is what that means. And then we also have ED, which is another maybe unfortunate abbreviation, which actually stands for extension data. Okay. So I'm an example person. I like to look at things in context. So what we have here is basically the object that we get back as the relying party from a client after a credential is created. So I've shortened this just a little bit just for brevity for the slide, but you can see there's a couple of key points here. There's a RP hash ID that we're looking at the top. That's been shortened because it's very long and would take up the whole screen almost. And then what we're looking at below this are those flags that we talked about on the previous slide. So we're going to break this down just to kind of give you an example of what this means. In this particular case, this was me registering a passkey with the iCloud passkey manager on my Mac, just to give you kind of a frame of reference for where this took place. So what this is saying is that user presence passed, that I was alive, I did some kind of gesture to be able to complete this authentication event and do this registration. I have Touch ID turned on, so user verification is true in this case, so I passed that check. Backup eligibility is a property that actually comes from where your credential is being saved. So in this case, those two things are coming from the Apple keychain. So backup eligibility says, yep, this credential could be backed up, and the backup state is set to true. So this means that this is a credential that could be saved across my iCloud keychain. I could then use that on a different device. These are the two flags that you'll typically see if you're using something like a syncable passkey, where you haven't set extra parameters on it. And then we get into a couple different things on the back end here. But this is kind of the basics of that object. What that will allow you to do on the RP side is interpret, how that passkey got registered, what properties were used to register that passkey with, and this becomes important in that interchange when you're registering. So, go. Just to give you a kind of contrasting example, this is the same registration process, but this time I've used a YubiKey security key instead. What you can see has changed here are those two backup eligibility, backup state. So I'm still passing my user presence check. I'm still passing my user verification check. I have a PIN protection on my YubiKey, so that checks out there. But the backup eligibility, backup state are different because, like Matt was saying earlier, since it's saved onto a security key and it was saved in a way to make it non-exportable, those credentials can never leave that key. So those are some of the values that you'll want to take a look at when you're going through this.
And I want to add real quick, between the backup eligibility and the backup state flags came about a year and a half ago when synced passkeys arrived on the scene. There's a nuance of the two flags. Backup eligibility is a signal that's intended to never change after registration. The idea is there a capability of the authenticator at registration time to make this appear for use on a different device? That should be true or false and should never change after authentication. Backup state, you can have, yes, true is what you'll often always see. False is another very popular one, but like true-false is just as valid. It's this is a nuance that is probably going to be handled by whatever, maybe you're using a library or to implement WebAuthn. Like that would be something that the enforcement of the values changing would be something the library would handle. But there's, like the user presence and user verification are way easier. Just check them, make sure one is true, and if UV is true, that's really based on whether or not you want to allow that. Google, for example, prefers user verification, but will accept a passkey ceremony that does not return user verification, because they've wrapped the ceremony in so many other trust signals checks to make sure that the user is in a recognized IP address or geographic region, things like that. So how you process these, there's no like single way to go, yes, you must make sure that these are true, make sure that these are false. It really comes down to your security modeling as an organization to determine which of these is a valid combination and which of them is not.
Yeah, so, and just to Matt's point, this becomes contextual information that you can use as the RP is really the point. So if we move forward, I think this is actually a good visualization of what Matt was saying. So there's a lot of terminology, there's a lot of different pieces that go into implementing a FIDO authentication event. Some of those are accessible to you as a developer if you're wanting to develop your own FIDO authentication solution. Some of those are provided to you by other parties. So the areas that you really have control over as a developer, if you're going to go back and you want to set this up for your services, for your internal sites, whatever you want that way, are the RP side, which is really that backend service API layer. And then the other side that you have access to is that service layer. That could be an application, it could be something like a web page. Those two pieces are in blue on this diagram just to kind of help you visualize that those are the boxes that you can play with, that you have a lot of control over. What happens as you move through the layers, though, is then you get into this client layer, which is typically provided by either a browser or an operating system, maybe a library, possibly. But usually those are fairly locked down. There's a certain amount of functionality that's provided to you by like iOS, by Android, by Windows. And as you're developing your applications, you're really going to be hooking into their libraries and their support on the OS level layer to do that. Below that, you get into the authenticator layer. And that's another area that is going to be predefined for you. So this is where you're talking to something like a security key. This is where you may be talking to something like a passkey provider or a password manager. Where this gets a little interesting is where on the RP side, you can request certain properties when you're doing that create credential call. The client layer, so that browser OS layer and the authenticator layer can choose whether they want to respect that or not, right? So I can say as the RP that I want to have, say, user verification always set to true. That property will go through this flow. It'll go down to the browser layer, the client layer, go through the authenticator layer, and then come back to the RP once that credential's been created. But I won't know if that request has been respected until I get that attestation object back as part of that create credential call. So just remember when you're looking at this, there's some nuance here. I think as a standards organization, we like to talk about this very holistically, try to make it sound like you can work with whatever layer you want. And when you go into like an actual implementation, you are working within certain boundaries and certain boxes. So make sure that you keep that in mind. Anything you want to add to that, Matt?
And I think that's probably the hardest thing for relying parties to get used to, is the idea that they don't have full agency over the ceremony with WebAuthn. There is, with three actors in play, both the website, the browser, and the authenticator all have different sensibilities about what makes for a good WebAuthn ceremony, what makes for a smooth WebAuthn ceremony. And what the relying party wants or may need because of regulations may not always be deliverable without applying additional controls backed by attestation.
Mm-hmm. Yeah. Okay. So this is where attestation becomes important. So without attestation, you, as the backend service relying party, have no way of knowing if the properties that you've asked for have actually been respected throughout that create credential events. So there's a little bit of a debate about whether people should attest, not attest. I won't get into any Shakespeare soliloquies here, but it is a decision that you have to make as a relying party. Attestation objects contain different information, so they contain the flags like we looked at before, so things like UV, UP, BE, BS. There's also some information in here called an AA GUID that can help you identify what material the credential was saved to. There's a credential ID, and then there's also an attestation certificate that all get bundled into this object. This is really your opportunity as an RP to do any kind of enforcement checks, any kind of filtering, anything like that that you want to do before you save that credential and make it active for that user to log in with. So this is your gate, essentially, as the RP, to get that information back, check it, make sure it matches what you want on the relying party side before you activate that credential. Up until this point, the credential is created on the client side, but it's not active until you actually save it on the RP side. And so this is your part where you can check that out. So why this becomes important is, in addition to just the flag checks, this also allows you to do some things like a GUID checking if you are in high compliance scenarios or you are doing enterprise application implementations where you may only want to allow certain types of authenticators. Maybe that's due to, say, like NIST implementation guidance, something like that. You can use the AA GUID to do that kind of filtering. It does allow you to do that last check before you save the credential, so that becomes important too. And then it can also help you just with things like reporting. So if you're trying to get a feel as a service owner, website owner, for how people are using passkeys with your service, this is where you can get some of that information. So that can give you a little bit of that breakdown of who's using, say, security keys, who's using, passkey providers that may be helpful for you in terms of developing better customer support, better engagement. In certain cases, though, this may not be needed. There are some instances where people have security concerns, privacy concerns. There's some presentations later this week that are going to be digging into some of those privacy details, but just know that's the embodiment, that's the decision you're making, whether or not you want to save the attestation object. All right, and then part of this, so once you have the information, somehow you have to check it against some kind of source. So I'm pretty sure nobody here has AA GUIDs just memorized and at the top of their head. So Matt's going to talk a little bit about how to make that work.
So attestation is a process. You verify part of the response, and if the response can be chained back to a make and model or manufacturer, you can then trust that AA GUID to make decisions about it. Now you have the AA GUID and you're the kind of high assurance RP that has a higher bar of registration for whatever reason, government regulation, personal and as much as that is a personal decision, personal choice around the kinds of authenticators you want interacting with your systems. So you take that AA GUID, once you've verified that it's valid, you can then trust it to look up information about that authenticator in the FIDO metadata service. This has been a service that's been around for a few years now, and it's essentially a massive blob of JSON that you can look up information about an authenticator by that AA GUID. And once you have that information, you can then look at the metadata, the additional information about the capabilities of the authenticator, like what public key algorithms is this authenticator capable of generating responses with. And you can go, well, I am fine with ES256, but maybe not RSA for whatever reason. And you can omit, like you can reject the credential at registration time so that that authenticator can't be used with your systems. For the most part, nobody needs to do this. I don't even put a percentage on it, but many RPs just need to get away from either a state where they have just username and password or they're using SMS OTP. You don't need to worry about any of this. But if you are an organization under government regulation, for example, to mandate a specific level of capability, FIPS is a really common one to frame this as. If you need to ensure that the authenticators logging into your system are FIPS compliant, you would use the FIDO metadata service at registration time, keyed off of that AA GUID to understand whether or not this authenticator satisfied that requirement. Excuse me. Now there's also a smaller version of FIDO metadata that you're going to start hearing information about. It's called the FIDO Convenience Metadata Service. Now the Convenience Metadata Service is a subset of the larger FIDO metadata. You're still going to pull down this information, you're still going to key off of that AA GUID, but it doesn't matter if the AA GUID is confirmed or not. These are not security posture information that you're getting from it. Rather, the information you're getting out of the Convenience Metadata Service are values that you can use to help style your presentation of passkeys to the user. Because often websites will have a sort of self-service aspect to passkeys registration where the user can go in and say, yes, I want to delete this one because I want to re-register or whatever. But FIDO Convenience Metadata Service will also enable RPs to offer a sort of branded vendor-specific presentation. In addition, light and dark mode on websites is very popular. So FIDO Convenience Metadata has considerations for that as well. So I don't have a TBD on when that's coming out. But you will hear news about it this week. And so thank you very much for your time. I think doing Q&A, or are we out of time? We're out of time. All right, well, thank you very much.
Thanks very much. And again, thanks, Karin, Matt. Again, we are on a really strict schedule because of the online folks, so we don't have time for Q&A, but we've got a break now until 11. And Matt and Karin, I'm sure you can grab them in the hallway and ask them what you need. Thanks, everyone.